All right, we're back. We are on page 5 of, I'm looking at my other computer, of Notes 26 for Calc AB. This is integration by parts. So if you're in Calc BC, this is definitely going to be on your exam. If you're in Calc 1 or 2 in college, I don't know, get good at it. So let's see. So we want to evaluate this integral. I look at this integral and I'm not immediately thrilled to be doing it. So I don't know. I mean, I could make u equal inverse sine and dv be inverse sine of x dx, and but then I have to integrate inverse sine, and that seems not great. So I mean, I've already done it, so I could just like scroll up and find that and then use it, but that doesn't seem like it's in really the spirit of this thing. So what I'm gonna do instead is I'm gonna do the u equals like something gross, and then dv is just dx, and we'll see. So I mean, I can integrate dv, so that's good. I can find the derivative of u, so that's good. The question is like the result. What do we want to do with that? So let's see. Du is going to be 2, so 2 sine inverse of x, and then times the derivative of sine inverse, which is 1 over the square root of 1 minus x squared, and then v is going to be x. Okay, so at this point we have the integral of sine inverse squared is x sine inverse squared, and then minus v du. Oh, I forgot dx. V du is 2x sine inverse of x over radical 1 minus x. So, okay. So minus the integral of 2x sine inverse of x over the square root of 1 minus x squared dx. Okay, so this actually doesn't look as bad as I was expecting it to, kind of, because I think that if I like keep things in the family and make another integration by parts problem where I make u equal arcsine, I can definitely integrate the 2x over radical 1 minus x squared, because that's actually almost perfect. So I'm going to do that. I'm going to say u is equal to sine inverse, oh my god, sine inverse, and dv is kind of the remaining part, so that's 2x over radical 1 minus x squared dx. And we can integrate that, and that's good. So 2x over radical 1 minus x squared dx. Okay. Okay. So du is going to be 1 over the square root of 1 minus x squared and a dx. And then v, all right, let's think. So it should have been negative 2x in the top, so I need a negative. And then it's like u to the negative 1/2, so it'll be 2, and then 1 minus x squared, and then it would be plus c. I always fight the urge to put plus c there. So you can like check and try to take the derivative of that. So like it'll be negative 2 times 1/2 is just negative 1, and then 1 minus x squared to the negative 1/2, and then times negative 2x. So that works, I think. So now what are we on? We are on, all right, so we're just going to go with an equal sign here for space reasons. And we already have this, x sine inverse of x squared minus parentheses. Okay, uv, so that's negative 2 root 1 minus x squared sine inverse. Okay, negative 2 root x, I don't know what I'm doing. Negative 2 root 1 minus x squared. My radical is insufficient. Radical 1 minus x squared sine inverse, and then minus the integral of v du. But if you multiply v and du, you actually just get negative 2. So it's minus the integral of negative 2. So that's plus the integral of 2. That seems questionable, but whatever. Plus the integral of 2 dx. Okay, so this should be x sine inverse of x. God, sine inverse squared is just like All the notations are terrible. 1 minus x squared, sine in, I'm being careful to distribute that negative. And then it's like plus 2x, but there's a minus, so minus 2x plus c. I don't know. Let's check. So should we check? It's more exciting to check by taking the derivative, but it's more annoying. So I'm not going to do it. But integral arcsine of x, and then that is squared, comma x. So x arcsine of x squared plus 2 root 1 minus x squared times arcsine of x minus 2x. So we got it. I'm like a little genuinely surprised that we got that on the first shot, but we did. And you know, it's just being neat and organized and willing to give it a shot. So I don't really see an alternative to this one other than making u initially arcsine and dv arcsine of x dx, and then doing like a separate integration by parts from there. Like, I mean, you could do that. You know, in some ways we did that, but I don't know. I don't want to delve too deeply into that. All right, this one looks a lot like a problem we already did. If you recall, we integrated sine of root x. So like maybe the same trick will work. So I'm gonna give that a shot. I'm gonna say w is radical x, and so w squared is x, which means that 2w dw is dx. And what substitutions can we make? All right, so we'll have the integral of x is w squared sine of w, and then dx is times 2w dw. All right, so the integral that we're going to try to deal with is 2 w cubed sine of w dw. All right, this is a classic table problem. Like, you know you're going to have to do integration by parts more than once. You know that the derivatives of w cubed are like super nice and they're going to work for you. Table problem. So let's say that u is equal to w cubed. dv is going to be sine of w dw. Okay, so we have in our table, we have u, we have v, and we have sign. And that's always going to go minus plus minus plus. So we have w cubed, 3w squared, 6w, 6, and then it'll be 0. So that column is actually very common. Like you'll see, you start with w cubed or x cubed like frequently. Here we go, the integral of sine is the first thing we're going to put in. So the integral of sine is negative cosine. And then the integral of that is negative sine. The integral of that is cosine. The integral of that is positive sine. Okay, and then you can check by taking derivatives. The derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of negative sine is negative cosine. So it worked. I was going from the bottom to the top there as I check. And this is always minus, plus, minus, plus. All right, so this is going to be 2. All right, so we multiply, so it's negative w cubed cosine of w, and then we just put a minus sign, minus. It's negative 3w squared sine of w, and then we just put a plus sign, and then it's going to be 6w cosine of w. Not going to fit it. Can I move anything? Oh, look at, I have so much space over here. Let's do that. You are all moving this way. I probably should have moved everything. Let's do that. Let's move everything. It's like, I will always think this is kind of like magical because you cannot do this on the paper that you're probably writing on. All right, so is it 6w cosine of w? There's going to be minus, because that's in the table, and then 6 sine of w. 6 sine of w. Close that. Then there's a plus c that I just like cannot fit. Plus c. Okay. Whew, we got to expand this now. So remember, w is actually the square root of x. So I'm going to use rational x. I'm thinking w is x to the 1/2. So I'm going to get negative equals -2 x to the 1/2 cubed, so x to the 3/2 cosine, cosine of x to the 1/2. And then it's plus 3x sine of x to the 1/2 plus 6x to the 1/2 cosine of x to the 1/2 minus 6. I still can't fit it. Sine of, this is terrible. We're all moving. So equals x to the 1/2. And then, plus c, but also, crap. So I forgot to distribute the 2 everywhere. So let's do this. Let's say it's, I'm just going to go back and change them. So this should be 6 because it was 3. This should be 12, which I'm going to have to really cram in. 12, and then this should be minus 12. I knew it. Every time I factor that out, it's like I know going in that I'm just going to get it wrong. So we got 266. I don't know. Let's go to the calculator and see. I'll be very impressed if this went right. And it makes me feel I really should have broken this up into more videos because I don't know that I want to be diving in and doing this whole thing again. X times sine of square root of x respect to x. So I need to expand. All right, let's see. What do we got here? We have a, how are you sorting this? I have no idea. -2 x to the 3/2 cosine of radical x plus 6 x sine inverse of x plus 12 x to the 1/2 cosine of x to the 1/2 minus 12 sine of x to the 1/2 plus c. Woo! We got it. All right, so let's go back. Let's do a slow scroll for screenshotting purposes. So here, I can't even here we go. So take your screenshots. All right, and then here, take your screenshots. Oh wait, you can't really see it all. There you go. I'm smiling for the pictures. And then that was it for this page so far. I'm just gonna do this problem right now, I think, because I don't want to come back in another video. So use shells to find the volume of the solid form when the first quadrant region bound by sine of x, x equals 0, x equals pi is rotated about the y-axis. All right, so presupposing that you know how to do shells. If you don't know how to do shells, then sit this one out. Not a big deal. So sine, like this. We're going around this. All right, so it's going to be 2 pi, the integral from 0 to pi of x, and then the height is sine of x, and then dx. Okay. You might have noticed all the integration by parts problems that we did were indefinite integrals. Yes. Do indefinite integrals. And then if it's definite, then at the end, throw it in fundamental theorem it. But do not try to change the bounds. Don't try to carry the bounds through. It's a nightmare. Always immediately change it to an indefinite integral. Do the problem, find the antiderivative, then use the fundamental theorem. That is my advice to you. That's what I'm going to do right now. So I'm actually going to do the integral of x sine of x, which we could table if we wanted to. uv sine, so x, 1, 0. The integral of sine is negative cosine, and then negative sine. So we're doing integrals, and then you can check them by doing derivatives. And then it's minus and plus. So this will be negative x sine of x, and then plus sine of x, and then plus c. But we're actually doing a definite integral. So this is going to be 2 pi negative x sine of x plus, that can't be right, negative x cosine of x. I could tell that I was wrong because I had the same thing twice. I was like, that doesn't make any sense. Okay, so we have this, and then good thing I had written so much when I noticed that. Cosine of x plus sine of x. And then from 0 to pi. Okay, so this, where can I move some of this? Some of this stuff's in the way. Let's see, you go over here. That is my favorite thing in the world. Like, maybe really. Not a lot going on in the world right now. It's pretty easy for that to be my favorite. All right, so this will give me 2 pi quantity. Plugging in pi gives me negative pi, negative 1, and then 0. Plugging in 0 gives me 0, 0, just a lot of 0. So what am I getting here? I get 2 pi squared. And that's a weird volume. Let's see what the calculator says. I did that pretty quickly, so I would not be super surprised if I got it wrong. Let's see, 2 pi times the integral of x times sine of x, where x is the variable. We're going from 0 to 2 pi. Negative 4 pi, what? X, 0 to 2 pi. What am I even doing? That seemed like a very unlikely volume. 2 pi squared. 2 pi squared. Nailed it. All right, so I'm going to go back to the notes so you can do your screenshots, which I kind of assume is how people are going through these. And that was it. So take your shot. Okay, and now I am going to end the video. So I will see you maybe in the next set of notes. Who knows? If this is all you're here for, then, you know, good luck on everything you do, but I'll see you around.